Hi, I'm Sean Higgins, editor for Aspire3D.com, and I'm here at the International LiDAR Mapping Forum 2019. And I have a bit of an interesting interview here because I'm at the Paracosm booth, where you have a handheld SLAM-based mapping system at a what's traditionally sort of a wide area mapping conference. And I'm wondering if you could tell me, what brings you here, and what sort of reactions have you had to your product?
Yeah, how's it going, Sean? So yeah, no, we're excited to be here. Again, my name is Amir from Paracosm, and we just thought it'd be cool to show up to what's usually a aerial airborne lidar conference with a handheld system. In part because we started getting a lot of our users using the PX80 system for street level or ground view lidar, and then registering it with aerial-based survey. So maybe it's like just a UAV photogrammetry is most common what our customers are doing. Maybe it's a LiDAR system, but a lot of our users are mashing up aerial with the PX80 to get this holistic point cloud of everything. And what's kind of cool is the accuracy of all the systems, lines up, and we get really good alignment between the different modalities.
So are there any sort of challenges to aligning these different modalities, do you say? Because in general, in the past, it seems like the industry has treated these as being two very separate applications, right? Either I map indoors, or I map a building, or I do wide area mapping, and they've never really connected.
So that's a really good question, and I think the answer is something we were just talking about earlier. A lot of people are used to the tripod or the TLS scanning, where they're used to 2 millimeter resolution and 3 or 4 millimeter accuracy of the tripod systems, and it turns out that in the vast majority of use cases that you want to do these surveys for, a few 2 to 3 centimeter accuracy is plenty good. So the 2 to 3 centimeter accuracy from a drone survey, the 2 to 3 centimeter accuracy from a Paracosm PX80 survey, mash up and align to each other just fine. And it turns out for overwhelming number of really important real world applications, 2 to 3 centimeter accuracy answers most of your problems. And it's more important to get a really fast, efficient scan of an entire area, street level view, building exterior, building flyover, building interior, having all that data in one unified point cloud that can be captured from one system really fast and easy is more important than millimeter level precision.
Right. So it sounds like at the ground level, on one extreme you have terrestrial-based tripod. On the aerial side, at one extreme you have Geiger mode, or like aerial. And then, somewhere in the middle with some overlap, it sounds like you have something like a SLAM-based system that can be handheld. Or often it seems like we're even starting to see those on UAVs. So there's like a natural overlapping of those technologies.
Exactly. I see that there's going to be a trend coming of SLAM-based LiDAR coming to small UAVs that can start to fly lower to the ground and in complex scenarios like bridge inspection and close to buildings where GPS isn't that great, and we're going to start to see SLAM converging onto UAV payloads, SLAM being used on backpack and handheld systems, and it's going to be useful for doing facility management, doing construction site inspection, doing architectural planning, forestry management. Because now, for example, let's just grab forestry management as an example. We not only get the canopy, but we actually get the terrain, what's going on underneath the canopy, we can see the details of the size of the trees. So combining modalities gets us so much more information, and it doesn't really matter that we're not at the millimeter precision of TLS. So yeah, like millimeter precision is not actually necessary to deal with your really thorny problems.